Hello all. All right, today we are looking at factoring sums and differences of perfect cubes, and then we'll also be quickly looking at mixed factoring. So if you remember way back, lesson 1 of unit 1, when we did a review of factoring, we saw the difference of squares and the perfect squares, and I said it's going to take it one step further this year, and we're going to look at factoring sums and differences of perfect cubes. So this is it. Okay, just as an introduction, we're going to multiply the following expressions. It's the same as expanding or FOIL. It's just our second bracket is now a trinomial, no longer a binomial. It has 3 parts, meaning we need to multiply each of those, or x by each of those 3 parts, and then we'll do y by each of those 3 parts again. Okay, so the x multiplied by the 3 parts in our second bracket, x times x squared is x cubed, x times negative xy is negative x squared y, and then x times y squared is xy squared. Then we have the y part, or the red. Y times x squared is x squared y. Y times negative xy is negative xy squared, and y times y squared is y cubed. And then if we want to collect like terms here, you can see that we have a negative x squared y and a positive x squared y, so they will cancel out. And we have a positive xy squared and a negative xy squared, so they'll cancel out. And what we're left with is x cubed plus y cubed. Okay, let's do the same thing with the second one. We're going to multiply all 3 parts of our trinomial by x, and then all 3 parts of the trinomial by y. So just quickly multiply here. We get x cubed plus x squared y plus xy squared. And then we have negative x squared y minus xy squared minus y cubed. And again, we can cancel out all the middle ones. So we are left with x cubed minus y cubed. Okay, so in general, what we just learned from that, when factoring a sum of cubes, so meaning that our first term can be cube rooted and our second term can be cube rooted, and this is a sum, so we're adding the two. Essentially, we will end up with x plus y as our binomial, x squared minus xy plus y squared as our trinomial. Okay, so basically the cube root of the first term will go at the start of the first bracket. You'll square it to start the second bracket. The cube root of the second term will end our first bracket. The square of it will end the second bracket. And in the middle part of the second bracket, you just multiply them together with the minus. Okay, difference of cubes. It's the same, but we're subtracting its difference. So this time we're going to get x minus y as our binomial, and then x squared plus xy plus y squared. Okay, so when looking at the two, you notice that the sum of cubes, the binomial or first bracket is positive, and then the middle of the second bracket is negative. For the difference of cubes, the binomial or first bracket is negative, and the middle portion of the second bracket is positive. It's the only difference here. Okay, on to some examples. So we have a first term and we have a second term, and we want to see if we can cube root both of these. So can we cube root 125. Yes, we can into 5. Can we cube root y3? Yes, we can to y. And then can we cube root 8? Yes, we can. It's 2. Okay, so essentially, again, sum of cubes, we end up with our first cube plus the second cube. And then in our second bracket, it's the first cube squared, so 5y squared, which is 25y squared. This one's the minus, and we do 5y times 2, so it'll be minus 10y. And then we end it with the second term squared, so 2 squared is 4. And that's the answer. Okay, next one. Just going to go right into it. So the cube of 27 is 3. The cube of a6 is a2. Remember, when you're cube rooting, sorry, I meant cube root before. You're cube rooting an exponent, you divide the numbers. Okay, so 6 divided by 3 is 2. 12 divided by 3 is 4. And then the cube root of our second part of 64 is 4. And C15 is 15 divided by 3 is 5. Okay, so that's our first bracket. The second bracket, now we're going to square each of those. So 3 squared is 9. A squared squared is A4. B to the power 4 squared is B8. Okay, it's going to be plus in this one, in the difference. And we're multiplying this first term by the second term. Okay, so 3 times 4 is 12. And A, B, and C, they're all individual there, so we just write them in like that. And then the last part of our trinomial, 4 squared is 16. C to the power 5 squared is C10. Okay, that's the difference. Sorry, just highlight that in purple so you know that's what we did there. Okay, questions to ask yourself whenever we factor. Many questions here. Is there a greatest common factor? Again, if there is, use it. It'll make everything a lot easier. Second question, is it a difference of perfect squares? So difference of squares, we looked at that in factoring in last year. Is there a sum or difference of perfect cubes? That's what we're working on right now. Is it a trinomial I can factor? So would substitution be helpful? Can I factor by grouping? Can I factor using the factor theorem? And is my expression completely factored? Okay, so number one, is there a greatest common factor here? And the answer is yes, there is, because they all have an x. Okay, so we're going to greatest common factor out an x. And that's going to leave us with x cubed minus 2x squared minus 5x plus 6. Okay, no more greatest common factors. Is it difference of perfect squares? No. Is it a sum of difference of perfect cubes? No. Is it a trinomial I can factor? Well, it's not a trinomial, so no. Can we factor by grouping? Okay, normally we factor by grouping when we have 4 terms. There is 4 terms, but it cannot be done by grouping. Okay, so we will use the factor theorem. And for the sake of time, I'm just going to let you know that 1 will be a factor of this, because that would give us 1 cubed minus 2 times 1 squared minus 5 times 1 plus 6, which equals 0. So 1 works. So let's divide by 1. We're going to use synthetic here. 6. Okay, carry the 1 down. 1 times 1 is 1. Negative 2 plus 1 is negative 1. So we have -1 to -6, which gives us our 0. Okay, great. So now we are left with x squared minus x minus 6. That is a trinomial that we can factor. So we end up with x minus 3, x plus 2. So if you don't remember, the multiples of 6 that subtract to 1, 3 and 2. Okay, the 6 was negative, so the signs have to be different. And -3 plus 2 gives us the -1 we're looking for. Okay, so now we have 1, 2, 3, and 4 factors here. Okay, so the factors of this are x, x minus 1, x minus 3, and x plus 2. Okay, number 2 at the bottom here. We're going to go through all of our questions. There's no greatest common factor because the first coefficient is 1. It's not a difference of perfect squares. It's not a sum or difference of perfect cubes. It's not a trinomial. We cannot factor by grouping. So we're going to use factor theorem. Okay, again, for the sake of time, I'll let you know that 1 factors out of this. I'm not going to write them all, just trust me. So let's divide again by 1. 1, 4, -2, -8, 1, and 4. 5, 5, 3, 3, -5, -5, -4. Okay, great. That's what we're looking for. And that gives us a leftover of x4 plus 5x3 plus 3x squared minus 5x minus 4. Okay, we go through all the questions again. Still goes right down to factor theorem. Again, for the sake of time, I'll let you know that 1 can come out of here again. So factor 1 out of here. We had 1, 5, 3, -5, -4. 1, 6, 9, 4. Okay, so we are left over with x cubed plus 6x squared plus 9x plus 4. Okay, this time 1 cannot come out of it. I'm going to go over here. But we can factor out -1. So 1, 6, 9, and 4. And we're left with x squared plus 5x plus 4, which then can be factored into x plus 4 and x plus 1. Okay, so for this one, a lot of, let me just do the one there, a lot of factors. But when we actually list them out, we get x minus 1 to represent the 1, but there's 2 of them, so we're going to put a squared. Then we have x plus 1 to represent the -1, and there's 2 of them, so let's put a squared. And then the only other one that's left is x plus 4. Okay, on to number 3. The last one we're going to work with here. And there's not a common factor here. There's P's and A's and Q's and B's, but there's not one thing that goes into all 4 of them. But we can look at grouping. There's 4, so let's try to group. And we're looking for common factors here. So the common factor of this first group is a squared. And when we take out the a squared from each of those first two terms, we're left with p cubed plus q cubed. And then in the second set, we have negative b squared as our common factor, and we're left with p cubed plus q cubed. Okay, so this leaves us with our two brackets of a squared minus b squared and p cubed plus q cubed. Okay, our knowledge of factoring tells us that this first one is a difference of squares. Okay, it's a squared plus b squared. Both of them can be squared. There's two terms, and there's a minus sign in between. So remember, back to factoring, it's a difference of squares. And then we look at our second bracket, and based on today's lesson, we know that it is a sum of cubes. Okay, so let's work this out. So we know that a difference of squares will get two brackets. We'll have an a plus a b and an a minus a b. And based on today, we know from our sum of cubes information, we'll have two brackets, the cube plus the cube, root, sorry. And then our second bracket will be p squared minus pq plus q squared. Okay, and that is our final